So now we're focusing on carbons that have a CO double bond for the most part. These are really, really important in biochemistry and medicinal chemistry, really all over the place. So we can break them up into two big classifications, carbonyl and carboxyl. Carbonyl are compounds that have a CO double bond and then other things to hydrogens or carbons. Carboxyl also has a CO double bond, but it's going to have an oxygen in addition to that, right? So the CO2 group. And again, some of these don't actually have this, but they're all lumped together because the rest of these derivatives are usually made from the carboxylic acid. Okay, but we're getting ahead of ourselves. Carbonyl groups. Again, as I said before, these can be hydrogen or carbon in these things. So compounds that have two carbons on either end, these are called ketones. Right? Notice no Y in ketone, right? So ketones, if you've heard about ketosis, how when people are on the South Beach diet, their body starts to break down their polypeptides, and they have this kind of like acetone nail polish remover smelling breath for a little while. That's called ketosis. So acetone nail polish remover is a ketone. It's got CH3s on both ends of this. So ketones have a carbonyl in the middle and then a carbon on either side. If there is a hydrogen on one of the sides, that is called an aldehyde. Okay, so aldehydes have a carbonyl with a carbon on one end and a hydrogen on the other. That's an aldehyde. And if you're wondering, there's only one molecule that has both hydrogens, and that is a particular aldehyde called formaldehyde. So the formaldehyde you might use in your biology lab looks like this. Kind of, we'll get into the details later on. So these are ketones and aldehydes. Again, carbonyl in the middle, CO double bond, and then carbon or hydrogen on the outside. Now, that's different from a carboxylic acid. A carboxylic acid looks like this. So it's got a CO double bond connected to an O, connected to an H. And again, its name is not misleading. These things are generally pretty acidic. So when we talk about acetic acid, vinegar is a carboxylic acid, or it's a very dilute version of acetic acid. Okay? So again, carboxylic acid, CO2 with an H on the end. If we put a carbon on the end of that, this is called an ester. Okay, so esters, very often used in flavoring compounds and perfume. They smell usually fruity and nice. Again, we're just looking at pattern matching now. Esters have a CO double bond connected to an O, connected to a carbon, not an oxygen. Okay. Also, sidebar, you might notice I'm not talking a lot about like OO bonds or ON bonds or something like that. Those compounds are much rarer than these. So OO bonds you might see in peroxides. They're not usually all that stable. And ON bonds are actually even more uncommon than that. So really we don't need to worry about those too much. So this is a carboxylic acid. This is an ester. It's almost like the difference between an alcohol and an ether. But again, don't cross up your esters and your ethers, even though the words look similar. Okay, so if I have a CO double bond that's connected to an N instead of an oxygen, this is an amide. Sometimes pronounced amide, sometimes pronounced amide. I like amide, but I don't think there's any one correct way that I care about. So first of all, don't get amide and amine confused, right? An amine has a nitrogen that isn't connected to a CO. An amide does have a CO next to that end. So it's this 3-atom grouping that makes it an amide. But like amines, you can have carbons here instead of hydrogens, and it's still considered an amide. These things are really, I know I've said this a lot, but this is maybe the most important functional group when it comes to biochemistry, particularly when it comes to protein folding. So amides are really important to understand. We can keep going with these derivatives. So if I have a Cl here next to my carbonyl, we'll call this an acid chloride. Sometimes we'll say acyl instead of acid, but usually acid chloride is an old-fashioned word, but it still works. Very, very reactive. Obviously, this carbon's got 2 electronegative atoms pulling at it, and so it's very electron poor. It's very, very rare that you would see either a fluoride or a bromide here. Those really don't show up in organic chemistry too much. And so it's really chlorine that tends to be the sweet spot. I don't think I've ever seen an iodide there. So when you're coming up with ideas of what this compound might be that you found, it's probably not an acyl bromide or a fluoride. Those are very, very rare. Acyl chloride. Okay. Again, very reactive at carbon. Another compound that's reactive like that, and that is very chemically similar to an acid chloride, is something called an anhydride. Now, with a name like anhydride, you might think that it's missing water, right? Anhydride sounds like anhydrous, sounds like dry. We took water away. And really, that is what this is. So if you compare this with a carboxylic acid, an anhydride is just 2 molecules of a carboxylic acid that lost water. Okay, so if I take 2 of these and I smush them together and I take out H2O, I get an anhydride. Okay? So again, much like an acid chloride, if I compare this carbon with this carbon, they're both pretty electron poor carbons with some electronegative atoms pulling electrons away from it. So reactivity-wise, these things are almost identical. So there's one more I want to talk about, and it doesn't look like it belongs. This is a nitrile. So nitriles have a carbon with 3 bonds to nitrogen, right? So it doesn't look like a carboxylic acid, but it shares the fact that it has 3 bonds from carbon to some electronegative atom. And really, you can say that about everything on the board, right? Esters, acid chlorides, amides, anhydrides, all of them have a carbon that has 3 bonds to something that is electronegative, whether it's oxygen, nitrogen, or chlorine. Okay? So, and again, we don't need to get into reactivity right now, but suffice to say that nitriles are made from carboxyl groups pretty readily. We can go back and forth between nitriles and carboxylic acids. Okay? So, again, big long list. Carbonyls, ketones and aldehydes. Carboxylic acids have lots of derivatives, esters, amides, acid chlorides, anhydrides, and nitriles. It looks different, but it acts like the rest of these things.